Welcome to a new lesson. One thing about living in China is I don't have free access to a lot of the useful websites. Because I made the videos a little longer and I couldn't upload them or send them through emails, so now I have to remake it. I have learned to enjoy saying the same thing more than one time anyway. So there we go. In this lesson, you're going to learn one property of each type of these triangles. First, right triangle. It says, in a right triangle, the sum of the measures of the two acute angles is 90 degrees. I hope you can see the words okay. What it means is, in a right triangle, there are two acute angles, and the sum of their measures is 90 degrees. It is very easy to understand because we know the sum of all three angles is 180 degrees. So 180 minus 90 degrees is 90 degrees. So we know the sum of these two angles is 90 degrees. With that property in mind, if you know one of these two acute angles, for example, if we know this angle is 45 degrees, then we would know angle A has to be 45 degrees too. That makes a triangle if they add up to 180 degrees. In some cases, actually in a lot of cases, the shape is not a simple triangle. It might have more than one triangles. In this one, angle A is 74 degrees, and work out angle DCB, this one, and angle B, this one. There are many ways to solve this problem, I believe. The one I started is, since angle ACD, here, angle ACD plus angle A is 90 degrees, so angle ACD is 90 minus 74, which is 16 degrees. And angle DCB, here, this one, DCB is, it is 90 degrees minus angle ACB, right? It's 74 degrees. And angle B plus angle C, here, angle B plus angle DCB is 90 degrees. So angle B is 90 degrees minus 74 degrees, which is 16 degrees. Did it make sense to you? Yeah, it's just the application of the property of the right triangle. Well, I hope, or I believe it made sense to you since you guys are all so smart. The property of an isosceles triangle is, let me get my pen. The measures of the angles opposite the equal sides are equal. What it means is, in this triangle, this side and this side are equal, and angle C and angle B are angles opposite these two equal sides. Angle A is the angle between these two equal sides. So it is saying that angle C and angle B are equal. Sorry. Before we learn more properties of triangles and angles, we can fold it in the middle and find out that these two parts are symmetrical and these two angles are equal. You need to be careful to not be confused. only these two angles that are opposite to the equal sides are equal. If you get confused with these angles and you think, oh, this angle and this angle are equal, then you're going to have incorrect answers. In this triangle, side AC and side AB are equal. Which two angles are equal? Right, angle C and angle B. So if we know angle B equals angle C equals 39 degrees, then angle A would be 180 degrees minus angle B minus angle C, which is 111 degrees. Now the last type of triangle. It says in an equilateral triangle, which is a triangle with three equal sides, each angle measures 60 degrees. How do we know? If we use the property of an isosceles triangle, we know that since xz equals xy, then z and y are equal angles, right? An equilateral triangle is also a type of isosceles triangle. And if we flip the triangle around, or if we look at in a different way, xy and xyz are equal, then angle z and angle x are equal too. Now we know that all three angles are equal. And since they all, the measures of all these angles, the sum of all these angle measures is 180 degrees. So each angle has to be 60 degrees. All right, let's see how we can use it in a question. A triangle ACD is an equilateral triangle. So angle A is 60, angle ACD has to be 60, and angle ADC has to be 60. There are different methods to solve this problem. If you remember the property of angles on a line, knowing angle ADC is 120 degrees, is telling you that angle CDB is 120 degrees because they make angles on a line, which is 180 degrees. And then, knowing angle ACD